Hi, in this video, we are going to learn about the real world problem. And for example, we are going to take the traveling salesman problem. Generally, the toy problems are used to illustrate the different problem solving methods and they are used to compare the performances of the algorithms. In this session, we will look into some real life problems such as route finding and traveling salesman problem. Route finding problem. As far as the route finding problem is concerned, we have to specify what are all the initial states, goal state, operators and path. Initial state generally will represent the starting point of the route finding problem. It could be specified as the current location of the traveler or vehicle. Goal state generally will represent the destination or the target location that a traveler or vehicle wants to reach. Operators will define the actions or movements that can be taken to transition from one state to another. In route finding, typical operators include moving from one location to another by following roads, paths, or other navigable routes. So in general, the operators will tell us the possible ways by which you could reach from the initial state A to the goal state B. Then comes path. This is the cumulative cost or the effort that are required to travel from A to B, considering the specific actions or movements taken along the path. Here, it shows the example for the previous four initial state, goal state, operators and path. Initial state, so this is going to tell you some specific location on a map. Example, the coordinates, latitude and longitude, or some named location. For a goal state, it is going to specify the traveler or vehicle wants to reach a different location represented similarly to the initial state. Then comes operators. Whether we move to the north or south, east, west, or directly you specify the routes. So depending on the complexity of the problem, it might include specific routes or directions such as take highway X or turn left at the intersection. Then comes path. Suppose if you use grid-based map where each movement from one cell to the adjacent cell, it has a uniform cost of 1, then the path cost would be the total number of steps taken to reach the goal state from the initial state. This is the second problem, traveling salesman problem. Here, the initial state, it's specification of the place from where the journey begins. Then comes the goal state. This is the goal, which means you finish the trip. Here, the salesman will visit every city exactly once and he returned to where he started. Then comes operators. In the traveling salesman problem, it moves means changing the order of cities visited. So he might be switching the order of two cities in the route, like switching city B and city C. Another move could be adding a new city into the route between the two existing cities. Then path. It is the path the salesman takes through the cities. It may begin from city A through city B, then city C, and so on. All the cities are visited and ending back at city A. In the traveling salesman problem, the goal is often to find the shortest route that visits every city once and it has to return to the starting city. While we solve this traveling salesman problem, we feel it is difficult. There are also other methods which find good solutions efficiently, especially for larger traveling salesman problem instances. In this session, we have discussed about the real world problems, namely the route finding problem and the traveling salesman problem. Thank you.